Example, we want to find the parametric equation of the line L passing this point. Similar example we have done before. We take the points A and B. This is my point A. The coordinates point A are -3, 2, and 1, and point B. Coordinates point B are 1, 3, and 2. Now here to find the equation of the line, I need two things. I select the point. Then the point B, point A, is -3, 2, and 1, and we take the vector. We take the vector as vector V. Is my vector AB. This is here. I have 2 points. I can write the vector AB. This is my vector. This is my vector AB, and this is my vector AB. And my AB is equal to 1 minus -3 is 4, and this is 3 minus 2 is 1, and we get here 2 minus 1 is plus 1. So my vector I get here 4, 1, and 1 again. 1 minus -3 is 4, 3 minus 2 is 1, and 2 minus 1 is 1. So I have here the point, I have the vector. I can write my equation of the parametric equation of the line. Parametric equation of line. We can have the value as x equal to x1. x1 is -3 plus a1t plus 4t. Y equal to y1. y1 is 2. 2 plus t, and z1, because b is 1, a2 is 1, is z1 plus t. This is equal to plus t, where t is any real number. This is part 1 of my question. The part 2 is I want to find where the line is intersecting xy plane. So what is the equation of xy plane? When you touch xy plane, at xy plane, we have the equation of xy plane is z equal to 0. We have here in the xy plane z equal to 0. So I take the last equation z is equal to 1 plus t, and put this equal to 0, then we t equal to -1. I get the value of t, I substitute the value of t, I'll get the value of x, y, and z, and that's my point. So my x is equal to -3 minus 4 is -7. My y is equal to 2 minus 1 is equal to 1, and my z is equal to 1 minus 1 equal to 0. So we say the required point is a point -7, 1, and 0. So similarly, you can also discuss the case when it's this my case P, when it's going to touch the yz plane. In yz plane, we put x equal to 0, or you can say xz plane. In xz plane, we take y equal to 0, and we get the points values. Putting in this equation, we get here the value of x, y, and z. That's our solution. So you can just see it. Then xy plane, we're having z equal to 0. In xz plane, y equal to 0, and in yz plane, x equal to 0. So we can get the equation of the any required point where the line is going to touch or intersect that particular plane. Now we want to discuss, we are given 2 lines, and we want to check are these 2 lines are parallel. I want to see these 2 lines are orthogonal. Well, it's very easy for us, because for example, we have here line L1, I have line L2. I want to find that are these 2 lines parallel. What I will do, I will just take here the vector parallel to the line. Here is my vector V1, and here is my vector V2. Now I check this vector V2 and V1. If they are parallel, then vectors are parallel. If the lines L1 and L2 are parallel, then vector V1 is parallel to vector V2. So that's the case 1. The case 2 is we have 2 lines. This is my line L1. This is my L2. I want to check this line L1 and L2 are orthogonal, making an angle of 90 degrees between them. So this is simple again as before. We take here vector V2 parallel to line L2, and vector V1 parallel to line L1. If these 2 vectors are orthogonal, then lines are orthogonal. If V1, we say if the lines L1 is orthogonal to line L2, this means the vector V1 is orthogonal to vector V2. And we have in the definitions when they are orthogonal, then we have the dot product of these two vectors is equal to 0. Then we say this is equal to 0. And when they are parallel, then we say v1 is equal to t times v2. Or the second one is we take the ratio of the component of the vectors, and if the ratio is equal, then we say these two vectors are parallel. Anyway, we can check this one. So the third thing is that we are having here the lines are parallel. Here they are orthogonal or perpendicular. I want to find the angle between two lines. We have here two lines. This line is L1, this line is L2, this is my L1, and this is my line L2, and I want to find the angle between these two lines. We say the angle between these two lines is angle between their vectors. We have here this vector is for the line parallel to line L1, and L2 we find the vector. This my vector is my vector L2 is V2, line L1 is V1. So my theta is equal to cosine inverse of V1 dot V2 over magnitude of V1. As we know how to find the angle between these two vectors, we can apply it and we can find angle between two lines. Angle between two lines. So this is, we use our vector knowledge to find it. Number one, they are vectors, the lines are parallel when the vectors are parallel. The lines are orthogonal when they are corresponding and vectors are orthogonal. Want to find the angle between two lines is same as angle between their parallel vectors. In this example, we want to determine whether the line L1 and L2 are parallel. Line L1, we have given x equal to 4 minus 2t, y equal to 1 plus 4t, and z equal to 3 plus 10t, t is any real number. And here x equal to v, y equal to 6 minus 2v, z equal to 1 by 2 minus 5v, v is r. So we have seen that two lines are parallel where the vectors are parallel. So vector parallel to line L1, vector parallel to line L1 is vector A, and the component vector A are, this here is minus 2, the x component, then 4, the y component, this A1, A2, and then here A3 is 10. So it's my vector parallel to line. Then I have the vector parallel to line L2 is my vector B, and my B1 here is my coefficient of B is equal to minus 2, and here I have here it is 1, then the y component is minus 2 and z component is minus 5. So these are vector A and B. So we want to see the vector A and B are parallel. We just take the ratio of the vectors. We take number 1, A1 over B1, then minus 2 over 1 is equal to 4 over minus 2 is equal to 10 over minus 5, and that we can see this is equal to minus 2. They all are equal. This implies the vector A is parallel to vector B, and this implies line L1 is parallel to line L2. So we can take as a note, we can use here the other way, that A is equal to T times B. We know here A, the vector A is equal to minus 2 times B. So this implies A is parallel to B, because we know what's our A. Our A is 2, we're having here minus 2, 4, and we're having here 10. And this we take minus 2 common, we'll get here 1 minus 2 and minus 5. And 1 minus 2 and minus 5 is our B. That means this is equal to minus 2B. So that's how we can check either by that way or this way, that how we can find these two lines are parallel or not. So implying the lines are, implies lines are parallel. Lines are parallel. In this example, we want to determine whether the lines L1 and L2 are orthogonal. We give a line L1 and give line L2. We have seen that two lines are orthogonal when their parallel vectors are orthogonal. So we can get the vector parallel to line L1 and we can get the vector parallel to line L2. So we say vector parallel to line L1 is my vector A. What is the coefficient of vector? This is -1, 3 and 2. -1, 3 and 2. Then we take the vector parallel to line L2. So what are the components of this one? We say is B. Components are 2, -4 and 7. 2, -4 and 7. So we say when these two vectors are orthogonal, the A and B are orthogonal. B are orthogonal if we are having the dot product of these two vectors A dot B equal to 0. We find A dot B of these two vectors. A dot B is scalar dot product A1 B1. This here is 1 -1 multiplied by 2 plus A2 B2. This 3 multiplied by -4 plus A3 B3 is equal to 2 multiplied by 7. So what we get here? We get here -2 -12 plus 14. And that gives me here -14 plus 14. The value of this one is equal to 0. This implies A is orthogonal to B, and this implies when two vectors are orthogonal, then the corresponding lines are orthogonal. Then L1, L2 are orthogonal to each other. That's the idea we have just developed, that the two lines are parallel when their corresponding vectors are parallel. Two lines are orthogonal when their corresponding vectors are orthogonal.